if the developed model or machine is not working as per our requirement. So that is called model optimization. Once this is done as a feedback, so develop mathematical model, write a mechanical program in computer, run the program. We call it testing and simulation. If you find that the system is not working as per our design, and you vary the system parameter, modify the material. For example, mechanical system is you modify what material you are using, what is your dimension of the material component, all those things will be modified. And once if you get the required output for a given input, then the model will be, mathematical model will be frozen. That is, we call a virtual prototyping. Once the model is optimized, then we develop what we call a physical prototyping. Using the output received from the virtual modeling, we will develop the mechanical system, making individual component and assemble the components, make the machine. Then we make the actuator or select the actuator which is needed to drive the mechanical system, and also install the buy or design sensors required for controlling the machine. Then, of course, we will develop also the electronic circuit, what we call signal conditioner, which is called as amplifiers and filters. Under this signal conditioner, there are two types of signal conditioner. One is called small signal amplifier, other one is called power amplifier. We will see all these things when we talk about the sensors and amplifiers. Separate lectures we are going to have, that time we'll see. Of course, when you use a digital controller to control the machine, which is called an embedded controller, we write software which is called as algorithm, which is going to control the mechanical system. That will be written using some language, maybe C, C++, or Python, some coding, and the program will compile and stored in the digital controller, which is called as embedded controller. This is a special purpose computer used for controlling the machine. And when you are using digital control, the sensor signal coming from the machine will be in the form of analog signal that should be converted into digital signal. That is done using analog to digital converter called ADC. Analog to digital, short form is ADC. Similarly, the computer generates, or digital controller generates a signal which is in the form of binary number that cannot be given to the actuator. So we have the DAC, which converts digital signal from the computer or binary number into continuous signal called digital to analog converter. This is what we saw in the previous class. Now we will go to next slide, in which we are going to see examples for mechatronic system. For example, we talk about autonomous car, intelligent car, or advanced driver assisted system, installed cars, something like new generation car, in which the engine is controlled, fuel is controlled in the engine using the fuel injection system, and the steering system will be controlled using what we call as steer by wire or assisted steering, electrical assistant, this one. And also we will be using braking system, which we call ABS system, and similarly this is assisted steering system. And this is engine control. These are the prime components of any automobile. And so these are electronically controlled. So we know that engine is a mechanical that is controlled using a ECU, which is called engine management system, with sensors and actuators needed. Like fuel injector is an actuator, spark plug is an actuator, and also use TPS sensor and inlet air temperature sensor, map sensor, like lot of sensors to control a mechanical machine. So it is an example. And overall vehicle also nowadays what we call autonomous vehicle, in which this engine, the steering system and braking ABS system will be controlled by another computer we called as vehicle controller. It is called as vehicle controller. This vehicle controller will be connected to a lot of sensors like radar, lidar, camera, ultrasonic sensor. These sensors will be installed various points of the vehicle, which can see the environment, and we call it perception, perceive the environment, and find out where is lane marking, where is obstacle, all those things like a human driver. This controller will control the engine, ABS, and assist, steering system, so that the vehicle can drive itself. We call as self-driving car, autonomous vehicle. So similarly, another example is what you call aircraft. Aircraft, you know that already autopilot. You are definitely, many of you are here. When this aircraft, we talk about, for example, this is a commercial aircraft. The figure is shown here, and it has engines, jet engines. These are called as actuator for this aircraft. By burning fuel in the jet engine, the thrust is created. Thrust is created, which makes the aircraft to move forward by controlling the jet engines. We have, these are 4 jet engines. Then, if I wanted to, only the forward thrust is given by the engine, but if the aircraft has to take off, that means go up in the air, come down from this one air, then you need additional control surface, what we call as flaps. Flaps are there. You can see that these are called as flaps, and you will have ailerons also here. These will be controlled so that the aircraft can take off from the runway and go to the cruising altitude, and again return back and land on the runway. That is done by controlling this control surface, what you call as flaps and ailerons. Then you have what we call as rudder. Rudder is used for turning the aircraft. Rudder is mainly used for turning the aircraft. These jet engines, the flaps and rudder are controlled by a pilot who is sitting here in the cabin. He is sitting in the cabin and he controls while aircraft is taking off or doing landing. Also, once the aircraft takes off from the runway, it starts climbing. They are called as climbing. That is the terminology used. Aircraft is climbing from 0 altitude from runway to per certain altitude, which is called as cruising altitude. Aircraft will be made to reach cruising altitude by controlling the flaps and the ailerons. So now the aircraft reaches the certain this one altitude. What is cruising altitude? Cruising altitude is around 30,000 to 35,000 feet. 35,000 feet. Generally, if you see that, around 10 kilometer height. Correct? That is the maximum height. Most of the commercial passenger come transport aircrafts which are going to transfer goods will be flying. So now this controlling the rudder, engine, and also flaps to make the aircraft to move in the runway, then accelerate further, then take off by controlling flaps so that the lift is created and the aircraft moves upwards and reaches the cruising altitude and flies to the destination. Just when the aircraft reaches near destination, pilot will again make the aircraft to climb down to reach the runway. That time also you'll be controlling the flaps and ailerons. And if the aircraft turn, then he will use the rudder. So this is done by generally doing takeoff, landing. The control of all the aircraft with the components will be done by the pilot. But once you reach the cruising altitude, and then many times there's a computer which is called as autopilot that will be enabled to maintain the constant altitude. I told you the height has to maintain 30,000, 35,000 for each aircraft. The ATC, air traffic controller, will give you a guidance on what altitude he has to fly. There are many flights are flying. At any given time, you may be around 20 to 30,000 aircrafts are flying around the world. So same in the same route, they call it route from, for example, Chennai to Bombay. The same route, at any given time, there may be 10 or 15 aircrafts will be flying, but one after another. So the aircraft, if you fly in the same height, then there are possibility of pollution. So each aircraft will be assigned such a particular height. I told you 30 to 35,000. For example, 5 aircrafts are flying in the same route with some this one. Each will be separated by 1,000 feet or 2,000. One aircraft 30,000, other one 31,000 feet, another 32,000, And of course, they'll be separated, but even one aircraft may be going fast, a bigger aircraft, small aircraft fly this one, depending upon the engine power. So even if it goes, it is not going to collide. The height will be maintained. So maintaining height is job of the pilot. But when it is cruising, they will engage a computer called autopilot, which will maintain the height and the speed as set by the pilot for the during cruising period. If I talk about this one, here the aircraft takes off and goes to a cruising altitude, correct? From the airport, this is the airport A, it has to the airport B, correct? So runway events, then it climbs to the required altitude, maybe within 10 minutes. Many of you would have flown. Pilot will say we reach to the cruising altitude. After goes here, the autopilot will be engaged. Will be engaged by this one, and it will fly the aircraft, maintaining the direction, which direction it has to fly, and also the height, and also the aircraft speed by controlling the engine, all these things. Whatever the pilot does, once it is near this destination airfield, then many times the pilot will say, put your seatbelt, all those things. We are going to land. Suddenly again, the aircraft will be controlled, so it climbs down and reaches the runway. During this phase, takeoff and landing, that time, definitely many times it will be controlled by pilot. During cruising conditions, the pilot can a little bit relaxed, but of course, it is still. So controlling the aircraft also is a mechatronics. Please, that engine is a mechanical system. The flaps, all these made of mechanical parts and links and joints that is controlled by using actuator. So the aircraft can be considered as a mechatronic system. Then, as a third example, it is not that mechatronics is there only in the vehicles and aircraft, that is advanced machines, even in the home appliances, like automatic washing machine. Automatic washing machine, here this is a picture which shows automatic washing machine. Okay, it has a lot of parts. We are going to see in subsequent a little more detail for this one, and in which we know that there is a drum which is called as tub, or sometimes called as a drum. In a drum, it will be connected to a motor. The motor will be controlled by a controller, electronic ECU, and the ECU will be connected to the panel where buttons, all those things were operating panel on the top of the machine, operating panel. That will be accessed by the user. For example, the end user is nothing but the person who is going to use the machine or the washing machine. He can control the washing machine by controlling the operating panel. Okay, we know that the tub may have capacity to 10 liter to maybe even 30 liter, 40 liter, depending on the washing machine size. That is water capacity, in which water will be filled using a pump, and there's a water level monitoring system, and also then you have a motor. Once water is filled, then you will put your cloths. Cloth will be put inside the washing machine. Then detergent will be added with water. Then machine will be made to wash, or what you call as start the machine, or washing cycle starting. During the time, the tub will rotate clockwise or anti-clockwise. Also, many times in the center of the tub, there's this one called agitator, moving part. We will see that it is called as agitator. That also will be connected to this motor. So, in this case, the drum will be moving. Generally, drum will not be continuously rotating during washing cycle. In washing machine, you have 3 cycles. One is called as washing cycle, other one is a rinse cycle, and other one is called drying cycle. This cycle, during the time, washing cycle, water will be filled in the tub. Already you put the cloth, and also the amount of detergent will be automatically added depending on the water level, and cloth will be put, then start the machine. So the machine is programmed by the washing machine manufacturer, and you can select how much water should be there depending on number of cloth you are going to wash. If the tub water level is for total capacity 15 liter, it can wash 20 cloths. Sometimes you may want to wash a lesser number of cloth. In that case, there's no need to fill 15 liter of water, it becomes waste. So in that case, you can select only half tank, or maybe in the control panel, there are options available. Correct? So you select the option, how based on number of cloths you are putting. Accordingly, the washing machine will select water level, and also amount of detergent should be added, and so that it makes the machine to operate and wash your hands and remove the water, and finally you can take and dry it out. So this is also another example for mechatronic system, because in the washing machine you are going to control the movement of the tub and also the agitator, and there are water inlet valve, outlet valve. Sometimes you want to wash the cloth with warm water. If you wash the cloth with warm water, it can remove dirt quickly, better than a cold washing. In that case, the modern washing machine may have water heater also. That water heater can be activated, and you can set the water temperature. Activated means you can set the temperature. What is temperature you want, whether 50 degrees, 60 degrees, 70 degrees, depending on type of the cloth. Correct. Some cloth doesn't require hot water. You should not do it. That we will see when we talk about it. So this is another example for mechatronic system. Well, another example is automatic coffee vending machine. Correct. Many times in office, or if you go to shopping mall, many times there will be an automatic this one. You can put a coin, or then by you can request for a coffee. Correct. Coffee, there are different variety. Just what you call a black coffee. Correct. There's no milk added. Sometimes with milk, under different ratio. How much milk, how much coffee powder or coffee liquid. Correct. So that will be added. All those things can be controlled in the vending machine. Can select different type of coffee, and accordingly the coffee making machine, automatic vending machine, is just 3 compartments. One is filled with water, and there will be heater. Using that, the water will be heated. You know that to make coffee, you need hot water. So there are water tank. There will be a milk tank. Correct. There will be one more compartment where you can put the coffee powder. Coffee powder can be added. Then there will be a control panel where you can select what type of coffee there. When you select that, accordingly, the hot water quantity and the milk quantity and also coffee quantity will be mixed automatically by opening appropriate valves, and then they will be mixed and finally dipped in the cup. So this is another example for mechatronic system. So not only these items, even robots also is a mechatronic system. Robo is used for doing some task, moving some object, doing some welding operation. This one in industry definitely would have seen on this one. We call it industrial robot. There are different type of robots. One is called a humanoid robot. This is a humanoid robot because the robot looks like a human. It has a head, it has a body, it has hands, it has legs, it can walk like human. Using hands, it can do many things. So this kind of robot is called as humanoid robot. So the humanoid robot example is this is called Asimo, developed by Honda Corporation. Honda Corporation knows that Japanese company which makes car and also this kind of robotic automation machine. Honda Corporation of Japan. So this has a body, correct, and to make the
Sorry to interrupt. Sorry, sir, sorry to interrupt. This class we already taken up. Today is like sensors and actuators you have to take up.
Oh, how come? Okay, sorry, you should have told. Okay, yes, but no problem. Now we have to go to sensor actuators. We started that, huh?
Yeah, you are showing the slide on last class. So
Yes, sir. It was covered on 3rd September, sir.
Oh, okay. Sorry, somebody should have told. No problem. Let me discount this. Let us start that. No problem. That is not issue. Let me start the recording now.
Recording stopped.
Okay. If you are told, definitely we would have gone that. No issue. We'll go to the next slide. Did we talk about sensors and actuators or elements of mechatronic systems?
Sir, we covered need for mechatronics, and we talked about mechatronic system like using RTOS, plant system, and all of that, sir. PI control and all of that.
Okay.
Digital sensors, feedback control, and all of that, sir.
Just 1 minute. Let me see here. Are you able to see slide? No.
Yes, sir.
Yes,
Yes, sir. Yes, sir. Yes, sir. Visible.
Okay. So now we saw the topics introduction. This one we saw. The example we saw or not? Automatic camera, washing machine.
Yes, sir.
Those
Those are completed, sir.
Huh?
Yes, sir. Satellite is completed.
Satellite completed. Engine we also completed.
Yes.
Engine we completed.
Park timing map and fuel map.
Yes, yes. This is the one, sir.
Oh,
Yeah,
okay.
pure need.
Okay.
This slide,
This way.
sir. Precisely
Okay.
this slide.
Okay. Thank you. Sorry.
We are also sorry, sir. We are also misguided you, sir. I think
Okay.
sensors and actuator also.
Yeah, we were talking. Okay, fine. Okay, fine. Now, you are able to see the screen now, correct?
Yes, sir.
Okay. Okay, now this off class over. I'll record separately. I will keep it, but anyhow, without recording, I'll continue my lecture. Okay, no problem. Okay, so we know what the important parts of mechatronic system. Thank you for bringing me to correct slide. Okay, now I remember we talked about plant. It is controlled by actuator. Yeah, embedded controller will be there. It requires some feedback, and we all talked about PID. All this fantastic. Yes. Okay. Now, since from this figure you can understand that plant is there, a mechanical system already there. Additional thing needed are sensors, actuator, and control system. These things should be added with the existing mechanical system. So the mechanical system become most efficient, energy efficient, cost effective, and perform better. That's why the whole idea of mechatronic itself. For that only we are going to add the controller. I told you it can be analog controller, digital. I still remember. Yes, digital controller. And if it is a digital controller, then you need DAC because the output will be a binary number that should be converted into analog. Binary to analog conversion is done by DAC. We are going to see about, don't worry about it. DAC, AD, how they work into all the things we are also going to see, including controller. And then, of course, the correction unit is nothing but the actuator. Correct, actuator. Then this is nothing but sensor. We talked about it. Okay, what are the various sensors used in this one? They said we know that you, depending upon type of machine you are going to control, you may use different type of sensor like acceleration, accelerometer, acceleration sensor, gyroscope to find how many degrees rotation is happening for a satellite altitude control. Because with respect to x-axis, whether the satellite is rotating, correct? Rotational movement can be used on gyroscope. Then tilt sensors, correct? Then piezoelectric sensors, which is called as, for example, strain gauges. Then metal detector, gas on the sensors. Please know you wanted to control your chemical plant, correct? Then you need gas sensor or leakage, all those things. Then temperature, pyroelectron, this is a temperature sensor, remote temperature detection. Then light sensor, which is called as LDR. Like this, you will see a wide range of sensor, force sensor, torque sensor, temperature sensor. So you may use a different type of sensor depending upon your requirement, including Hall effect sensor, all these things. Similarly, when you talk about actuator used in mechatronic system, it can be electric motor, a simple DC motor, correct? It can be a servo motor, or it can be a stepper motor, depending on type of motion. We are going to talk about this. It can be engine also. Correct. If your mechatronics is a big machine, for example, crane, correct. Now you are using crane which can do automatically. And many machines are controlled without driver. The driver sitting in the machine. You can sit on this and remotely control. In that case, you will controlling the engine. The engine can be actuated. Then you can have hydraulic motors instead of electric motors. You can have hydraulic motors or pneumatic motors. Correct, depending upon the availability of the energy source. Correct. So electrical power can be used, or hydraulic pressurized fluid, or pressurized air. We call it pneumatic motors, or IC engine, or even gas turbine can be used. as I told you that mechatronic means we are talking about aircraft, a jet engine, correct? And you use a helicopter. Again, it is a jet engine. We call it gas turbines or power plant. All these things are examples. So you have this kind of different kind of sensors. Then definitely the important, one of the most important part is what we call ECU, electronic control. It is nothing but a digital modern control. So control used in mechatronic systems are digital controller. They are nothing but a small computer. So it will have a CPU, central processing unit. Many times they use what we call a microcontroller. Okay, so keep the in mind. We are going to talk about it when we talk control system. Generally in computer, you call as microprocessor. General computer, your laptop, desktop, supercomputer, or your office computer, any computer, CPU will be a microprocessor, and you will have memory. Correct? Memory, there are three types. One is called ROM memory, other one is called RAM memory, RAM, other one is called hard disk or CD-ROM or pen drive. These three are called as secondary memories. Note down, they are called as secondary memory. The ROM and RAM is called as primary memory. In any computer, you will have two types of memory. One is called secondary memory, other one is called primary memory, and you have a CPU. And of course, you will have input device. Other one is output device. What is input device? In a computer, keyboard, mouse, and pen drive. Because you can send copy the program from some other computer using pen drive or CD-ROM and bring it to your computer again, so run the program. So even CD-ROM, pen drive are called as input device, and commands are given through mouse by clicking or by keyboard by entering the command. So they are called as input device, and your screen, computer screen, printer, plotter, all these things are called as output device. So this is general purpose computer. So in general purpose computer, microprocessor used will be generally, if I talk about PC, you have i3 processor, i5, i7, right? If you go to Apple computer, if you're using Apple laptop, you may have Power PC. That is CPU name. You may be using, if you open and see, it will be a Power PC made by a company called Motorola. Correct? The i7, i3 also made by Intel. There are many companies making the CPU or microprocessor used in different companies, including NEC, Fujitsu, Toshiba, Japan, and Infineon in Germany, and Intel, Motorola. There are many companies making different ECUs. That is microprocessor. They are used as main part of computer because central processing, which is going to do the computation by running your program. So similarly, in case of embedded controller also, you need a CPU. This CPU is called a microcontroller, not microprocessor. We'll see what it is. The microcontroller actually has microprocessor plus memory and ADC plus DAC. All these things are needed for controlling a machine. In computer, you don't need ADC. The general purpose computer, you don't need DAC. Only what you need, microprocessor and memory. But in case of embedded controller, the ADC, DAC is very important because you are going to read the signal from sensor that should be converted to a digital signal. So you need ADC, analog to digital. Similarly, the computer output should be given to the actuator. Actuator like motor, servo motor, DC motor, heater, or any other, this one solenoid. They want a continuous analog signal. Computer, after the calculation, microcontroller generates a digital signal that need to be converted into analog signal. That is done by digital, this one. So these two things are additional things. And another thing is, in the microcontroller, all these things are put in one IC, which is called a chip or integrated IC or chip. In single IC, microprocessor, memory, ADC, DAC, all these things will be put in a single to save weight and the volume. Correct? Because embedded controller had to be very compact. Unlike the general purpose computer. In general computer, microprocessor will be separate IC. Memory will be separate IC. And you don't need ADC, DS, all those things. So that's why. So in microcontroller, one of the main difference is the computing unit called CPU or microprocessor plus memory where the programs are stored, RAM memory and ADC, DS all packed in a single IC. That's why it's called microcontroller. And this is used for controlling machine. Instead, that's why we call it a microcontroller, not microprocessor. Processing means doing calculation in computer science. So that it is not just going to do computation, it will compute using CPU, microprocessor, and generate control signal. The signal will be given to ADC or DAC so that it can control the machines. That is why it is called as a microcontroller. So all your embedded control system will have microcontroller, not microprocessor. So this is microcontroller, and of course other ICs may be there, circuits, all those things, which is called a power amplifier, correct, and other circuit, power supply units. All those things will be made as a single printed circuit board, and they will be enclosed in a watertight compartment with a heat sink, all those things. So here you will connect the devices, power, correct, sensors, signals will be coming, power will be coming, then this goes to actuator. Actuators are outside, correct? So this is the main connector. It is a standard. I took the photo from internet. This shows standard embedded controller, which is called an open ECU. They say many times they call open ECU. This ECU you can buy and you can write your program control algorithm and store inside your embedded this microcontroller memory, because it has a memory also, so that this microcontroller can be made to control an engine or a brake system or a steering system, satellite, washing machine, or any application what we say into an aircraft. Anything can be controlled. Only thing is you change the program, correct? That is called control program, and store in that so it can be made to run. So this is another important part. So before going deeper, since still we are looking at the why you need mechatronics, what is mechatronics, what are the components needed in a mechatronic system apart from mechanical system we are seeing. When we talk about developing a new mechanical machine or a system, as we saw any of the items, there are thousands of examples. Machine can be like a washing machine, correct, coffee making machine, an aircraft. It can be a missile, it can be a satellite, it can be a car. Inside car, there is a very subsystem, like engine, brake system, steering system, correct? And any of the application you want to design, we need to follow some procedure. Generally, when we talk about machine, means it is I told you before the mechatronic system come into, our mechatronic way of controlling machine come into practice, which happened only some 30 to 40 years before, predominantly for the last 30 years, only 25 to 30 years. Before that, the use of electronics in controlling mechanical system are very limited. Mostly it is manually controlled by this one. There's no electronic sensor. That's why I talked about, including cars. Right? So during early days, before mechatronics was there, if you wanted to design a machine, what you were doing, first thing is you need to get an idea of the product. Correct? You want to develop a new machine, correct? Yeah, washing machine, correct? From the convention, you may make a mechanical sketch, correct? Hand drawing. You will make, what you will do is you draw a hand drawing. Okay, that hand drawing, using the hand drawing, correct? Once you get the idea, first you make a hand drawing so that you won't forget. After that, you make product design. From hand drawing, you have to product design. What is product design? First thing is you making engineering drawing or product drawing. Sometimes they call engineering drawing. You will use mini draft, although drawing board, you cut front view, side view, correct, top view, the 3D view, all those things you create to, and you give what the dimensions of each components. Correct. A machine may have 10, 20, 30, 50 components. Each component will be drawn. Correct. And to a scale. And you give the dimension. You create what is engineering drawing. Once engineering drawing is created, what you do, the drawing will be given to the prototype making or component making, which is nothing a factory. Correct. Each part of each drawing will be given to appropriate this one using, for example, lathe, correct, milling machine, drilling machine, or shaping machine, any machine use, each component will be made using mechanical operation. It will be made by the operator. Once the components are made, the component will be assembled to make the subsystem. Then the subsystem will be, for example, take a car, engine into crankshaft, camshaft, valves, piston, cylinder, and everything will make, and bolts, nut, all those things. Then you assemble, make the engine. Similarly, gearbox will be made. Similarly, transmission system will be made. Similarly, the brake system will be made. Steering system will be made. So these are called subsystem. Each one has multiple components. These components will be assembled, subsystem will be created, then finally assemble and make the car. So we will make the machine. Once the machine is made, then you will be start testing your machine. Please note that many times, even individual component you test. First, you make a bolt, you make a connecting rod, whether it will work, how much load it will withstand, all those things you will always look into by testing individual component. And if something goes wrong, again you make a new component. So the material is not withstanding. You made it aluminum and it is not withstanding, then you go to, for example, brass. If brass is not correct and load is already, you know that how much. Of course, as an engineer, you know this one. Sometimes maybe to save cost, to quickly machinability, correct. All these things matters when making a product. You cost effective, and products should be able to made quickly, but still it should solve the purpose and be able to withstand the load, all those things. So you may change the material, dimension, all those things, and during testing, if something fails, you modify. That means you'll go back. Again, you go back to drawing. From testing, if something fails, you go back to drawing, change the dimensions, change the material, again make the components, again testing. Like this, component level you do, testing will done at subsystem level, and then you assemble machine also be tested. If now once you do testing is over, and if everything succeeds, then you may make the working prototype. Correct? Then the working prototype will be again tested. On final testing over, you launch the product. This is how the mechanical systems are done. These are steps you noted. Please note that these steps involve a lot of time, efforts, correct, cost, and material, all those things. So if you want to, this is called a design procedure, design cycle, product development cycle. We call it product development cycle. This is what done for last thousands of years. Any mechanical system, whether they were making chariots 2000 years before, or now you are making a car 50 years before, or your aircraft, all these things, when the electronics control, automatic control was not involved, this is all the machines were made. Correct? Make a drawing, correct? Get an idea, make a hand sketch. From hand sketch, you make the engineering drawing, which gives the dimension, material, all those things. Then make individual component, test it. If it fails, again remake. Correct? Change the dimension, all those things. Again, so the cycle was going till the product is okay. One product comes. By this time, you would have made many prototypes. Correct? Physically, you have made each and every component. And if it fails, again make. You can see that because of that, you have spent a lot of time, lot of efforts, human efforts, cost, material, raw material buy. If it fails, that material you cannot use. Again, you have to make a new raw material. Again, you have to do the machining operation. Of course, you can say that the failed material melted again. And you know, this is going to spend energy, time, all those things. So finally, develop the machine. So this is conventional design. I call a note down. This I call a conventional mechanical design. This is what followed for thousands of years for design mechanical machines, correct? But these are not efficient in terms of time, effort, cost, or making product, or design cycle, correct? So if you take longer time develop a new machine, your competitor will launch a new machine if he is able to succeed. So that means you want product design cycle should be reduced, right? So that I can save a lot of efforts after this one. So that's why the mechatronics comes in picture. Mechatronics, how it makes it. Now, that's why I told you here, this slide, if you remember. This, please remember. So virtual prototyping. This is called virtual prototyping, means I design mechanical component, correct? Mechanical subassembly, mechanical full machine using AutoCAD, and test it using FE analysis. I use dynamic analysis. And if something fails, I change the material. Everything you can do. What you need is a computer plus the software, correct? The appropriate software. AutoCAD to make 3D modeling. I can do animation. I can do FE analysis. I can failure analysis. I can do all these things. I'm doing without making physical machine or physical. Nothing is made, and I can make a machine most efficient final design using computer. So they call virtual prototype because machine is not there, but you are able to visualize in the screen or 3D projection. Nowadays it has come, all those things. You can see that entire, including aircraft, missile, everything. So I can save a lot of time, efforts, all those things quickly I can do. Once you optimize your design using prototyping, then you make the physical prototype like earlier days, which is conventional. This is conventional design. Correct? In conventional design, I make the actual physical mechanical system based on the virtual prototype, all the dimension, all material, everything already selected size. So that can be transported to CNC machine. From virtual machine, correct? From AutoCAD drawing, you can connect it to CNC machine. So you need not make the drawing also. Directly what a computer that can be taken with the CNC machine, fix the appropriate tool. Once you put the raw material, you do all the machining, everything it does, final products comes out, correct? So quickly. So similarly, since mechatronic system needs the electronic circuit, I can design the electronic circuit, correct? Electronic circuit, what I saw that just now we saw the open ECU, correct? You have to select appropriate microcontroller, what are additional power supply circuit, power amplifier circuit, all those things. I design a circuit using PCAD or PSpace software and do the analysis, all those things. Physically make, that is called virtual prototyping. Again, PCAD, PSpace, all the software are running only in computer. I'm not going to make PCB, I'm not going to buy the component, nothing. Correct? Just like mechanical design, I do everything using computer. Again, virtual prototyping. Control algorithm, I develop using MATLAB simulating. So once all those things are there, we develop mechanical system prototyping, physical prototyping, electronic circuit, and also software. I store it in the embedded controller. Embedded software will be put in I test the actual machine. So I can develop new products much faster than conventional mechanics. This is called as mechatronic way of designing the machines. Okay, that's what I wanted to tell. Now going to end, because I want to close this introduction. Next class I wanted to start about the sensors used in mechatronics. So already we saw that. Now to enumerate what the different. So we saw conventional design, correct? Already we talked about it. So the mechatronic design, what I told just now only, extensive use of computer and software, please take the notes. Okay, because in exam you may be asked what is the difference between conventional design and mechatronic product design. Correct? Show the difference at least 8 or 7 steps. Okay, external use of computer software packages to model, correct? Mathematical modeling, writing equation in terms of input, output, and system parameter, and then do virtual modeling of the component or subsystem or system using creating 2D or 3D drawing in case and models, correct? 3D model, for example, AutoCAD. In case of mechanical, already I told you, I'm not going to repeat. In case of computer, this one electronic circuit means PCAD, correct? In case of control system, is MATLAB. These are software. This is for mechanical. This is for electronics, circuit design. This is called for control system. They all are going to run in computer only. Correct? 3D modeling, create complex 3D model product design, mechanical parts can be made, and you can assemble the components using 3D assembly in AutoCAD. There are many software. Then computer animation you can show and visualize whether the made product is working properly. 3D visualization possible. Once that is done, then you do testing and optimization. Correct? You got an idea, correct? Then you made a very 3D model using or 2D model, generally 3D model of the individual components. You do testing optimization. For testing optimization, you do with FEA package for static testing. Dynamic testing, you may use Adam. I gave an example only because there are many software, dynamic test, static, and there are different packages. And like this you do and optimize design. When optimize design, finally this is the whole thing is called virtual prototyping. Right? This is called a virtual prototyping. Then you go for physical prototyping. Once design after physical prototyping you will do. Correct? Similarly for electronic circuit, because mechatronics and electronic control system is there. Controller, ECU, that should be developed using PCAD, PSpace, and all the software, virtual user, then make the physical prototype. Similarly, control system software, you develop, then finally the software will be loaded inside the embedded control, it works. This is how it works. Note down the important steps. So this is mechatronic product design. Okay. So finally, I'm giving this figure. Correct. So whatever this is called mechatronic product design. Whatever you discuss here, I put as a flow chart. Not only flow chart. In exam, you may be expected to write. So this is called mechatronic product design. Okay. First, collecting input, that is getting an idea. Correct. Once idea you got it, you collecting data, then you could do the concepts and design. What are the parts? If the mechanical system, what should be there? Engine means you know that there should be a crankshaft, there should be connecting rod, there should be a cylinder, piston, correct, and inlet valve, outlet valve, the inlet manifold. What are the component needed? Correct. All those things you have to get an idea. Functional description. Then you write the mathematical model. We are going to see next class. I'm going to start with mathematical model mechanical system to understand. Correct. So you write the mathematical model of the subsystem or individual component and using first principles. We'll see what is first principle next class. You just note down this. Then you also model sensor and actuator, and also you model control system, and then the electronic circuit also. Correct. Detailed mathematical model, electronic control system. Then you do the testing. Correct. As I told, what we talked about, test you virtually by applying load in FES software and using P-space, apply voltage, how much current, how much power the electronic circuit takes. And apply input and see how much output is coming, control system using MATLAB simulating. So you do the design optimal. The cycle will be going again till you get the optimal product, whether mechanical, electronics, and control. Once that is done, you develop the hardware and test it in the test bench. Correct. We call the electronic circuit will be developed using hardware in test loop. Mechanical system will be tested in test bench. Correct. Engine means you are going to connect to the dynamometer, the new engine, and apply load. All those things will check whether it works. When everything is there, then you put the control software. The one control software is applied, then the machine cycle ends. So this is how the product development cycle. These steps you have to note down. Okay. So I will stop here. You have next class. Tomorrow no class. And from Wednesday we have class. Okay. Tomorrow no class is an institute holiday. Enjoy your holiday. I don't know whether a company holiday. But we will see continue from here in the next class on Wednesday. Anything if you want to ask question, you can. So hereafter, please use this Zoom link only. This is what will be used for teaching this course for entire semester.
Okay, sir. Okay, sir.
Okay. Thank you. Give your chat message as attendance. We will see on Wednesday evening.
Thank you, sir.
Thank you.
Thank you, sir. Thank you so much, sir.
Thank you.
Thank you, sir.
Thank you, sir.